Hi, welcome to Iron Health Talk with Dr. Akram. I am Akram. In this program, we'll be talking about all kind of different health issues with different experts in the field. But today we're going to talk something really important, the real origin of COVID-19. So sit back and relax, enjoy your time with us. Let's see. February 26, 2020, the first French patient, a 60-year-old teacher, died in a hospital. He was from Oise. The following day, the second victim was admitted to University Hospital of Amiens. He was also from same region. Interesting enough, both of them hadn't been to China or had connection with someone returned from China. Then, USA, Japan, Italy, UK cases spread early in 2020. And there was a ship in Atlantic. It all went well until one after one the holidaymakers fell ill with fever, sore throat, malaise and loss of taste. Soon after, the diagnosis was made, a novel coronavirus infection, later identified as COVID-19. What is the possibility of these people having contact with Chinese wet market in Wuhan, or it's infected people from Hubei province? We all still believe the virus jumped from bats to pangolins and from pangolins to human in a wet market in Wuhan, China. How is it possible for this infection to spread that fast and kill a few 100,000 people around the world? Was it possible person-to-person transfer to occur that fast? Have we thought about any other possibilities? Have we thought about the past pandemics, the plague, the Spanish flu, how quickly it devastated our society? Have we ever gone out of a comfort zone of thinking and imagine if the infection fell on us from above? Will it be possible? Are there any evidence for that? Have you ever heard that super infections can fall from the sky? Collisions of comets and asteroids on Earth that is laden with life not only destroys life, brings new genes in the form of viruses to boost evolution. There are over 100 billion habitable planets in the Milky Way. And as our solar system throws genes out into stellar space, some of these could certainly reach other life-bearing planets. In this way, the whole Milky Way is one connected biosphere. Today, we are here to talk about the possibility of infections coming from space. We have a pioneer guest in this program, Professor Chandra Wickramasinghe. Professor Chandra Wickramasinghe, a professor in astrophysics in the University of Buckingham. He was awarded a PhD in mathematics from Cambridge University in 1963. At Cambridge, he was elected a Fellow of Jesus College and served as a staff member at the Institute of Astronomy. In 1973, he was appointed the head of Department of Applied Mathematics and Mathematical Physics at Cardiff University. He is currently an honorary professor at Buckingham University. Out of his 350 scientific papers, many are published in Nature. He authored and co-authored 30 books. His exceptional career took him to many universities worldwide where he held visiting professional appointments. Professor Wickramasinghe holds honorary doctorate from Soka University of Tokyo, Japan and University of Ruhuna, Sri Lanka. He is a recipient of numerous prizes. Let's welcome in our show Professor Chandra Wickramasinghe. Hello, Professor.
Hello, nice to be on this show. Thank you.
Thank you very much for agreeing to be with us in our show, sir. It is our pleasure to have you in our show. How are you doing today?
I'm fine. Enduring the lockdown and the punishment that we're all having to suffer for the coronavirus, but that's our lot.
Exactly, that's right. But today we're going to talk something really important because lots of people believe what they believe, and we're going to talk something different. First of all, do you believe that COVID came from bats via pangolins to humans in a market in Wuhan?
Well, the short answer is no. I don't believe it. But having said that, I think I should fill in on the background to why people say this, and people say it so often that most of our public are coming to believe that this is an irrefutable fact. It is not an irrefutable fact in my view. Of course, the coronavirus, for instance, does infect other species besides humans. In fact, as you mentioned, bats and pangolins and lots of other animals as well, other mammals as well. But the story that the virus that came to humans in sort of late 2019 was a switch of an animal virus, and the animal virus got to be a bat virus. That virus got into a pangolin, and then through the pangolin to the human. And the wet market, as you said, was implicated or was allegedly implicated. But if you really analyze that, and my colleagues in various places have analyzed that, that claim is very, very difficult to maintain. The jump from the bat, the genetic jump from the bat to the pangolin to the human involves many, many, many random changes, very specified random changes. And the probability of that happening anywhere in the history of the planet is absolutely almost zero. So I don't really believe that.
Okay.
But,
okay, that's very good. Thank you very much. And the next question is, has it made in China or in America in a lab?
Again, I mean, that if you make that statement, it is not easy to disprove it, because you can make a virus nowadays. Biotechnology is very advanced. You can take a coronavirus, a common cold virus, and do lots of genetic engineering in the laboratory and produce a new form of the coronavirus that could be harmful. And of course, if you release large numbers of it in one place, say in Wuhan or tropic over Wuhan, then the spread takes over. But I don't think there's any evidence for that. And the evidence, in my view, favors a natural event that brought the virus from outside of the Earth to the Earth. And Wuhan happened to be the first place that it descended on. And then from there, of course, there was further. What happens, I should tell you, is that this virus probably came in a icy cometary bolide, as they say, sort of lump of ice that came out of the comet, which is, in our view, I'll come back to that later, our view, full of cosmic microorganisms, bacteria, and viruses. So this lump of material came probably over very northern part of China, exploded, released all this viral cargo into the upper troposphere, into what's called the jet streams, right? And those jet streams are moving very fast around the world. They move, there's a northern jet stream and a southern jet stream, and this, I think, happened in the northern jet stream. And so it fell, first of all, it broke loose into China, into Wuhan in a big way, and then kept on sort of cruising around the world.
But you are telling that the virus is coming from space, is that right?
Yeah, I mean, if you say it in that way, it's almost might sound ridiculous to people, but it has to be, that statement has to be seen in a much bigger context. And the bigger context is that life itself on the Earth arose from cometary microorganisms, from cometary bacteria and viruses. So
thank you very much, Professor. I'm going to hold it because we're kind of reaching the time for our quick break. And what we do, we will go for a quick break and we'll talk more about the virus coming from space. Hi, welcome back to Iron Health Talk with Dr. Akram. Today we are talking about the real origin of COVID-19, and we're going to talk a little bit about Panspermia. This must be something new, or you would have read about it. And in our show, we have a special guest, Professor Chandra Wickramasinghe, Professor of Astrophysics, and he's sharing his expertise with us. And let's go back to Professor Chandra Wickramasinghe. Professor, can you explain us, can mainstream science explain why some disease suddenly appear on Earth, cause massive destruction, then it just goes off and it comes back again?
Well, I think that is a very interesting story that runs through recorded history. The history of the world has been punctuated by pandemics, epidemics that start suddenly and then run its course and disappears. Sometimes those epidemics are recurrent, they lie dormant for maybe tens of years or hundreds of years and then repeat and reappear. But this is a continuing pattern, and one of the earliest pandemics that have been talked about in history is the so-called Plague of Athens in
Plague
classical
of Athens,
Greece,
yeah.
in 429, 429 before the Common Era. Okay, so
429
these
years, yeah.
guys, the Athenians, were at the time fighting, having a war with the Spartans, and during that war, uh, the Athenians suddenly went down with some illness that is very, very tragic. Lots of people died. And it was recorded, the whole epidemic was recorded by a historian named Thucydides. So we have very detailed accounts of what happened. And it is really highly reminiscent of what's happening now in the world. This epidemic came suddenly. Many of the great guys in Athens thought that the enemy, which is the Spartans, had poisoned their water supplies. They didn't at that time. They didn't know that epidemics are caused by viruses or bacteria, but they thought the water was poisoned. And so this is very similar to what we are saying now about China releasing a virus to the
It's
rest of the
releasing the
world.
virus, yes. What did
Isn't
we
it? It's
learn from
amazing.
yes, what did we learn from
Yeah,
the influenza?
yeah, that is very interesting because I think influenza holds a clue to this whole episode of pandemic and the whole story of pandemics. The most devastating influenza pandemic in recent times, in the last couple of centuries, was in 1918, 1919. Right? This was during the First World War.
First World War,
And
yes.
it is well documented, the cases are documented, the deaths are documented, and it is believed that more people died from influenza in the pandemic and the influenza and in the two world wars together. So something like 30
Together.
million people died. But
30
what's
million
really
people
very
died, yes.
interesting about this pandemic is that the first attacks of the lethal variant of this influenza appeared on the same day, exactly the same day, in Boston and Bombay, right?
That,
And this is
that's
19,
that's very interesting. So the infection appeared in the same day in Boston and Bombay. How is it possible?
Bombay.
Those days there was no air travel, and the ships took months to travel, and a war was going on. How is it possible?
Well, it's impossible. So this is why I think that story and similar stories hold the key to where these new viruses, new disease-causing viruses come from. They fall from the skies. Just imagine a cargo of influenza virus of this new type, right? It's a new type of virus because that's the reason that people got badly affected. This stuff was deposited in the stratosphere at 50 kilometers above the
So
Earth's
50
surface
kilometers above on the sky it was there,
on the
and
sky.
it
Yeah,
descended slowly.
it descended slowly into the troposphere, where all the rain clouds are, and then it fell just where the rain clouds broke, where the meteorological conditions were appropriate. So, falling at the same time in Boston and Bombay in 1918 from the weather is no problem. But as you
Yeah,
said,
that
I
that
mean,
that explains a bit more for our viewers, I think, because we went back to influenza. You said the influenza appeared same time in Boston and Bombay, and it came from space. But if it came from space, how did the space get this influenza? How come it came there?
well, that's why we have to go back to the whole bigger picture of panspermia. The idea that
Panspermia,
life,
exactly. That's what we're going for.
yeah, that's the reason that all this happens, and that's the only logical explanation. And the explanation is based on the fact that there is no there is no good understanding of how life originated and evolved on the Earth if there was no input from the cosmos. So our theory is that comets carry the bacteria and viruses and bring these to the Earth. The first time this happened on our planet was 4.2 billion years ago. Right?
So
So now,
4.2 billion years ago, the first life came from with comets to the Earth.
first life came with comets, and
What
then the
about
old
exactly? What about the theory we all believe there's something else, isn't it?
well, the theory that we all believe or been taught in the school when we were
Exactly.
children is that there was a primordial soup that developed in the oceans and chemistry that happened between organic molecules, between inorganic and organic molecules, somehow led to the first simple self-replicating living molecule or living structure. Now, there's
Is
no
that possible in a laboratory setup?
no. Scientists for the last 100 years have been trying to do that, and they have not succeeded.
So
The
it's not
reason
possible.
for them
Yeah.
not succeeding is that the information that is needed, I mean, it's okay having organic molecules, that's not a big deal. Building blocks of life are simple, right? They're like amino acids and so on. But you've got to string these together in extremely precise arrangements if you're going to get anything like a living system. So the odds against that happening on the Earth in a primordial group is 0.000. There's no chance of it happening,
Okay,
right? And
that's very interesting. It's the odd is really low, but now you're telling the life came to Earth from space. It's
yeah,
called
if you
your theory
expand,
of
yeah,
panspermia. Shall we discuss
that's right.
about this a bit more?
Yeah, I mean, panspermia, the idea of panspermia is very old in terms of history. The old Vedantic literature in India states that life was an eternal component of the universe. At the time of classical Greece, which is supposed to be the starting point of Western culture, Western civilization, there was in about 500 BCE, for the Common Era, a philosopher scientist called Anaxagoras. Okay, and he said that he maintained that life is integral, is part of the universe. Seeds of life are everywhere. Whenever conditions are right, these seeds get together and form living systems. And that he called it pans, meaning everywhere, and spermata is like sperm, spermata seeds, so seeds everywhere was his idea. That essentially goes back to Vedic time.
Let's talk about your
Uh,
research. I think you've been doing research for a long time, even before I was born. Research on this panspermia and with your collaborator, exactly.
yeah,
Shall
yeah,
we explain a bit more about what you have
yeah,
done in this aspect?
yeah. I think the way we started was within this. Our research was well within the confines of astronomy. It was astronomical research. If you look at the night sky, you see the Milky Way, a band of stars that stretches across the sky, and in between those stars there are dark patches, sort of really all shapes like elephant trunks and snakes and dragons' heads and what various shapes. Right? And
Yes.
these dark patches have been a mystery for a long time. Until the 1960s, when I began to research on these things, people had various ideas, but they turned out to be wrong. Right? So I began to investigate the properties of this material, which is essentially dust.
So
like that. Like,
essentially it's a dust. What we see there is this dark
and the dust is
images.
yeah, and not dust like in your house or anything.
Exactly.
It's we found it in our investigations over a period from 1960 to 1979. We found it was bacteria and viruses, and these were the main components of cosmic dust. Okay?
So
Now, how does
bacteria
this
and viruses can thrive in the sky. Is that right?
can survive in the sky? Can survive.
Can
They don't
survive.
thrive. They need to get into a watery environment in order
Okay.
to multiply, replicate, and do its biology. And so the comets are the important component of the story. The comets
How does
collect.
comets help them?
The comets mop up this. When our solar system formed, the outer regions of our solar system, this is 5 billion years ago, or nearly 5 billion years ago, was was a swarm of comet type bodies. And a single comet is about 10 kilometers across. Right? They're not small objects, they're 10 kilometers across. And they're made mostly of water, organics, and rock. Okay. And there's radioactivity inside the comets. So the interior of comets have warm, watery interiors.
Okay. Professor, we're going to talk more about the comets and how we transport the viruses and bacteria after the break, because it's a time for a quick short break, and we're going to see you afterwards. Is that all right? Thank you very much. Hi, welcome back to Iron Health Talk with Dr. Akram. Today we are talking something really important. This is about the real origin of COVID-19, which is something different than what we believed. And in our show, we have our special guest, Professor Chandra Wickramasinghe. He's a professor in astrophysics. So far, we have talked a little bit about how the sky could shed viruses on the Earth, and how it came with comets through, and it was dropped in the stratosphere, then it slowly descended to Wuhan. What we're going to talk more in the program, how could the comets harbor this organism? How is it possible? And where does this organism come from? How does it get into the comets? And then we will explain a bit more why this infection spread in this pattern, especially in the same area as Wuhan, if you see. Okay. Professor, welcome back again on the show.
Okay, thank you.
Let's go back and talk about these comets, and how could comets harbor these viruses and bring it towards our Earth or different planets?
If you see a comet in the sky, what you see is a tail of dust and debris that's been thrown out from the comet because it has come too close to the sun, evaporating, it's producing a long tail of material. And it is this tail of material that contains bacteria and viruses. And if such a tail interacts or crosses the Earth's orbit around the sun, Earth's path around the sun, then you would get bits of this comet coming into the Earth through the stratosphere. That's the connection that I think we have to.
Okay, once it comes to the stratosphere, what happens to the comet? Why doesn't it come to the Earth?
Well, sometimes, very rarely, a comet hits the Earth and causes a lot of damage, like in at the time of the extinction of the dinosaurs, 65 million years ago. I think that a small comet, hit the Earth, struck the Earth, and you can actually see the crater in the bottom of the seabed in the Yucatan Peninsula. So that happens, but very, very rarely. Most often, the material from a comet is in the form of dust or meteorites, right? Meteorites that sort of from sizes of sort of little lump of rock to a huge boulder and bigger things also. They fall into the sky, fall through the Earth, and survive. right? And so this is the way that even the smallest virus particles can enter the Earth's atmosphere and survive. And we've got to remember that if you look at the Earth's surface, it's full of human life is very small. Mammalian life is very small. The overwhelmingly dominant life form on the Earth is microbial. Right?
Microbial, yeah,
Uh,
that's right. That's true with
yes.
the and even with the sea, isn't it? There's plenty of
Yeah,
viruses.
yeah, absolutely. If you take a single drop of ocean water, right, go out into the sea where you're closest to where you're living and take 1 drop of ocean water, that drop of ocean water contains 1 million viruses.
Million
1 million
viruses. Exactly.
viruses.
And there was, I
And
think, I have read in one of your articles that you were talking about Sierra Nevada. They did some
oh,
tests and they found
that
viruses.
was yes, that's very, very interesting. This is only 3 years ago. A group of international scientists, Americans, Canadians, Europeans, they went to the top of the Sierra Nevada mountain, right? Which is at what 4,000 meters or something, and they had collecting devices to collect everything that rained down in the mist and the rain fell on collectors. And what they found was that every single day, 600 to 700 million virus particles fall on the Earth every square meter.
So
So take a one
every
square
day,
meter of the
600 to
Earth,
700 million viruses
million
falling to.
virus particles fall on
Wow.
the Earth. Right? It's
So
a
this coronavirus
staggering.
is
It's
something not very new. So this is
nothing.
one another virus.
Yeah, well, I think the way they got over that is to say that if they want to be conservative, they would say that those virus particles were lifted from the Earth's surface in pandemics or whatever,
Right.
and then fell back in the rain, right?
Exactly.
I mean, that could be a small component. I think even in the case of viral pandemic like coronavirus, they would get the stuff that is lifted from, say, from Wuhan, a large number of
Can
people,
you
person to
explain?
person.
Yes. Can you explain us how come it fell into Wuhan? How was the Himalayas effect on in Wuhan, and how does it spread around the world? Because we said the coronavirus did not go from human to human to spread from China to USA to Japan and other places. We said you said it spread from the sky. How did this happen?
Why is it China? Why is it China? Okay, that's an interesting question because all of the diseases that I think we can locate recently, like influenza, new pandemics of influenza always seem to start in China, right? And what happens, in my view, and according to our point of view, is that the Himalayan mountains are the biggest, are the tallest mountains, right? They essentially puncture a hole into the stratosphere,
That's true.
and
Yeah.
it's like a bathtub. So if you have cometry, viruses, bacteria deposited in the upper troposphere, right, at 10,000, 20,000 kilometers, then the Himalayas essentially pulls it down.
It pulls it down. That's right. And how did
That's
it
what happens.
spread in that area? You said it's a northern latitude.
Yeah, I mean, this is only a guess and a conjecture, but if you think of injecting a large number of virus-sized dust particles into the troposphere, right, into the jet streams, then the jet streams go around the world, swirl around the world at a latitude of 40 degrees, and that's where most of the first attacks of these pandemic outbreaks took place. But I mean, this is not to say that person-to-person spread is not important. That is a very, very important. Once the virus comes down, then person-to-person spread is very, very important, and that's the reason why we're all locked down these days, isn't it? We
So
want
I'm
to
going to ask a
minimize.
question here. Even though the viruses come from sky, we still have to protect ourselves, wearing masks, taking vaccines. Do you believe in this one?
Well, I don't know. I have myself taken the vaccine, so
Exactly.
I've got to say I believe that it is
So
useful.
we still have to protect, isn't it? We have to still follow the WHO guidelines, the hospital
I,
guidelines, the
I think it's
country
important. I
guidelines.
think it's important
It's
because
important.
it is an infective agent. Wherever it came from is not is important, but it's not as relevant as protecting the population from spreading what has already come down.
And I'm going to ask you something that you have written a letter or to a magazine or an article that you have warned the governments that there is a pandemic coming. That was in 2019, even before the coronavirus started.
Yeah,
Can you elaborate a little bit on it?
yeah, yeah. What we said was that at times when the sun is very active, right? It's called sunspot maximum. There are many spots
Sunspot
that you can see,
maximum.
right? Uh, at these times, the Earth's magnetic protection, right? There's a magnetic field that's called the magnetic sheath around the Earth. That that gets disturbed and sort of broken apart, right? So just imagine a comet coming outside of that magnetosheet and throwing out these particles. In normal times, the magnetosheet would limit or impede at least
The
the
magnetic
descent of
sheath
these.
will impede the descending of viruses or the
Yeah,
comet.
yeah, yeah. So if you break your sheet, if you break a magnetic sheet, then anything that comes close by, any comet, any asteroid that comes close by, could shed particles, and those particles would come right through to the surface of the Earth.
Letter, what kind of reply you got for that letter?
Well, it was just ignored because
It was.
it was so outrageous.
Why is that mainstream scientists, they don't want to believe in this theory of panspermia and the viruses coming from space and the life came from space?
Well, I think it's the intensity of the propaganda that is going on. I think people are so moved. If you say something enough times, people believe it. So if I keep telling you on the radio, on the television, the virus came from China, it was manufactured in China, or that it came from pangolin bats, then people will believe it. But the truth is quite different. I think to get the truth, you've got to really analyze things without the prejudice that is around.
The story of the virus jumping from bats to pangolins to human, it sounds like a Western movie
Movie.
story. It's quite interesting and how it could travel that fast and kill huge amount of people within short time. And even though the air travel was kind of restricted at that time, and
Yeah.
as I said in my opening speech, the first French patients who died in France,
Yeah. Yeah.
they didn't have any contacts. And even Italy, it was similar, isn't it? The Italian
Yeah.
person they
Yeah.
suspected.
There are many. Yeah. I mean, as I kept mentioning earlier, I think person-to-person spread is important. But the first attacks in many of these places where there were big outbreaks remains a mystery. For instance, even in Sri Lanka, the cases were sort of almost very, very low until a definite particular moment in time, and then it rose very suddenly. Right? And so whenever that happens, people say that it has to be a case zero, a mystery case, or someone who has come into the community and not undergone the quarantine or surveillance.
True,
And that may not be the case. I think and those instances are probably examples of direct infall, not person-to-person spread. So it's a case of direct infall followed by person-to-person spread. And that's what happens in all pandemics. In influenza, in the 1918, 1919 pandemic that I talked about, the first attacks were in Boston and Bombay, and then it spread out from there.
And before we close off, now we have said that the virus is coming from space. What can we do in the future to prevent or to be aware of it? What kind of advices you give us or the governments?
Well, I think what I would like to say is that it is possible um, to uh, to predict the infall of these pathogens maybe 1 or 2 years, maybe even more than that, a few years before it happens. And to do that, you've got to have surveillance of the stratosphere. You've got to have balloons. You've got to have instruments taken to maybe to the space station.
Actually, you have
And
sent some. You have in collaboration with Indian Space. You have sent some balloons, isn't it?
well, we did that, and this was a while ago, 2011, and we found lots of bacteria, and people haven't taken any serious note of it. But this is a very important way to protect ourselves, to monitor the skies for our safety.
Exactly. Thank you very much, Professor. I think we are coming to the end of the show. It was really great explaining all about your research, which you've been doing for a long time, and you have explained us about the real origin of COVID-19, and we have talked about Panspermia, and we have talked how the comets could bring different organisms, viruses and bacteria from different part of the world into us, and that actually sometimes it harms, and most of the time it helps us as well, because we also got about 33% of the viral gene in our body. So thank you very much for being with us in this show, and for all of you, for if you have any more further questions, you can always write to us in our Facebook, YouTube, or Instagram. Otherwise, we're going to see you in our next program. Thank you very much, Professor, for being with us. See you in our next program. Thank you.